This conference will now be recorded.
Okay. What do you understand from push operation? Can you tell me what do you understand from push operation? What is the meaning of push operation? Adding the elements into the Okay. What is the meaning of pop operation? What does pop operation do? Yes, we have to get pop operation is nothing but deleting the element from the top of the stack. You are going to remove the elements which are present at the topmost position in your stack. And what is the peak operation? Yes, can you tell me what is the peak operation? Yes, very good. We don't modify the stack in case of peak operation. We just get the element which is present on the topmost position in the stack. Yes? And peep operation is to print the elements of the stack. I hope everyone was clear with the implementation part of array, stack with using arrays. Anybody has any doubt with respect to the stack of array implementation? Yes, can you quickly type in into the chat box if you have any doubts, yes or no, so that we can move ahead? Clear? Fine. So in today's session, we will start with the stack linked list implementation. So what do you understand from this heading that stack will be implemented using linked list? It means that the operations that we are going to carry out in stack, that is push and pop, we are going to follow that by using the linked list implementation. Can you tell me what is a linked list? Yes, what is a linked list, guys? Okay. Data structure where data is connected by nodes. No, Paulson. This will not be the appropriate answer. When you say data is connected by nodes, means what? How are you trying to speak here? Okay. You have to say that data is stored in the nodes and the nodes are connected. Okay. So when you go for interview, people will expect that you put the things into a very simple manner. Okay, what you are telling would be an overview of that. Fine. A node which contains data and address of the next node. Okay. A series of nodes which are connected to each other. So now with this understanding, now we know that what is a linked list. Linked list is nothing but a linear data structure that consists of sequence of nodes, and in these nodes we are going to store our data. And also this node consists of one more part which is used to store the address of the next node. So here in this stack using linked list operation, we are going to implement these three functions. That is, insert an element. We will see how to push the elements into the stack when our stack is in the form of a linked list. Then we will see how to delete an element from the stack and then print the topmost element present in the stack. So here we will implement a single linked list. Okay, you can implement stack using double linked list as well. But here we will study with respect to single linked list. So using a linked list, we will create a stack of variable size. This is very important term. When you go for interviews, this is what you have to specify, that when you're going to implement stack using linked list, that is only because when you want a variable length stack. If you don't want a variable length stack, in that case you have to implement it using array. Okay, now let's start the first operation, that is the push operation. So here I will take a top pointer. To keep the record of the elements, I will take a pointer here and initialize it to null. When the stop pointer is equal to null, it means that there are no elements into the stack. Or you can say there are no nodes into the stack. Let's say we try to insert the element into the stack, and this operation is called push operation. So I want to add, let's say 10. So in order to add this 10, I will create a node. After creating the node, I will update the data value and the link part. Now I have one node into the stack. So I will update the top pointer with this node address and then return success. Let's say I wish to insert one more data, that is 20. In that case, again what I'll do, I will create a node, update the data value, and now see here, this is our topmost element. So the top pointer should always point to the top element, right? So I will update the top pointer. Can you tell me what will happen if I update the top pointer with this new node address? Yes, you are right, Paulson. We will lose the starting node. Correct? We are going to lose the address of this first node. So we cannot update the top pointer directly. Before updating this top pointer, we will establish a link between the new node and the first node, and then update the top pointer with this new node address. Let's say another push, create a node, update the value, establish a link, and then update the top pointer. In this way, we can add the elements into the stack. I hope you're able to follow this. Push operation is clear, guys. Yes? Okay. Now, can you tell me this push operation is similar to which operation of your single linked list? Very good. It is similar to insert at first function. Your insert at first function is same like your push function in case of stack. So when you implement this, you can simply copy that insert at first function and rename it to push function here. Fine. So now let's see how to delete an element from the stack. To delete an element from the stack, we have to call the pop operation. And when we call the pop operation, we will delete the element which is present at the first position. So here, in order to delete this 30, if I delete it directly, we will lose the address of the rest of the nodes. We don't want to do that. So what we will do? We will take a temporary pointer, initialize it with top, and then delete this node using the temporary pointer and update the top pointer. One more time, let's say if I want to delete the first element, update the top pointer, delete this node using the temporary pointer, and then return success. Can you tell me this is similar to which operation? This deletion is similar to which operation of your single linked list? Yes, it is same like your delete at first function. So when you are implementing stack using linked list, you have to simply use your delete at first function which you have implemented in case of linked list. You can just copy and paste it in this folder and rename it to pop operation. Rename the head pointer as the top pointer. Okay. Now let's say I have these three elements into the stack, 10, 20 and 30. And here in the peak operation, I have to print the topmost element present in the stack. Now can you tell me which is the topmost element present here? Yes, can you tell me which is the topmost element present here? Very good. It is top of data. Wherever the top pointer is pointing, that is the element which is present at the topmost position. So that we have to print, which is nothing but 30. I hope everyone is able to follow this. Okay, Shahul, I will repeat it. See here, when it comes to the push operation, initially we will take one top pointer and initialize it to null, which means that the stack is empty now, right? Now let's say if I want to add the elements into the stack. In that case, here I'll be creating a node. Can you tell me why I'm creating a node here? Let's say if I want to push any data, I am creating a node. Can you tell me why I'm creating a node? Okay, stack is empty. What is another reason? What could be another reason to create a node? Let's say here if I want to push 20, again I'm creating a node. Why I'm creating a node? Now the stack is not empty. Then why I'm creating a node? Okay, can I not directly just put that data in any format and implement this push operation? Why specifically I'm creating a node? Yes, anybody from the class? Yes, very good. That is because I am implementing stack using linked list. And in linked list, we store the data in the form of nodes. So to add any data, I will create a node, update the value. But here, when I'm creating a node, I have to follow the last in first out principle. See why we updated this top pointer to the next node? That is because we have to make sure that when I call the pop operation, I should remove the topmost element, that is 20. And that can be done with the help of this top pointer. Okay, so this is somewhat similar to your linked list concept, but here you are going to follow last in first out principle. I hope you are able to follow. Now if you update the top pointer to the next node address, this first node address you might lose, so you have to establish a link first and then update the top pointer. I hope you are able to follow now, Shahul. Yes. Okay, another push: create a node, add the values, establish a link, and then update the top pointer with the next node address. This is similar to insert at first function. Now, when you want to delete the elements from the stack, in that case, what we will do, we will create a, see, if I directly delete this node, I know that in stack I have to follow the last in first out principle, which means that I should delete the topmost element present in the stack. But if I delete 30 directly, I will lose the address of the previous nodes. So before deleting this, I'll take a temporary pointer and initialize it with top, and then update the top with the next node address and delete this. Another pop, delete the topmost element using the temporary pointer. This is similar to delete at first function. I hope you are able to follow. Pop function is clear. Yes, guys, is it clear to everyone? Shahul, is it clear? Okay, now let's see the next operation, that is the peek operation. Here what we are going to do in the peek operation, we have to print the topmost element which is present in the stack. You can see that the top pointer is pointing to 30. So here in this function, we are going to simply display this. We are going to print the data, that is top of data, which is nothing but 30. I hope you are able to follow now, Shahul. Yes, is it clear to everyone? Okay. Now let me just share the assignment sheet with you people. See, your assignment 12 is about stack list.c. Okay, so here what we will do, you have to implement stack using linked list. So you have to implement all these operations. Okay, so you have to implement this function. See, your assignment 12, assignment 12 is stack using list. So for this, what you can do is you can just copy your linked list assignments which you have done and paste it in this folder assignment 12. Okay, but renaming you should do. See, here you should have one main.c file. Same, your linked list whatever you have created, the same thing you can copy paste here, but here you have to rename the functions. You have to rename the head pointer to the top pointer. Okay, here you should have stack.h. This will be your header file. Okay, and one stack.c file. In this file you should have the push operation, or I can say the push function, and then here you should have the pop function, peek, and last one is your peep function. See, here it is going to be like this. If you copy paste all your linked list functions, this push function will be nothing but your insert at first. Only thing is that you have to rename it. Okay, this will be your delete at first function. Peek function you have to implement it, because we have not implemented any function like peek function. Peep function is your print function, but here you have to also check with your top pointer. Okay, so I will not write the print function here. This is to print the elements of the stack. This also you all implement. So basically you guys have to just implement this 3 and 4, that is two functions. These you all have already implemented. Okay, you just copy paste these things from your linked list assignment folder to this folder and do the renaming. And here I want you to rename the head pointer to tail pointer. Okay, not tail, sorry, this should be top pointer. I hope this is clear to you people, how you are going to implement this stack using linked list. Anybody has any doubt for this assignment? Okay. Now tell me what should be the deadline for this. See, peek function is just one line function. You just have to return top of data. Correct? Peep also is just like your print function. Now tell me what should I keep the deadline for this? Tomorrow is the deadline for your array implementation of stack. Can you tell me what deadline you want for list? Yes, tell me. Should I keep it as 18th? 18 should be fine. Am I audible, guys? Okay, fine then. We will keep this deadline as 18th because you just have to implement these two functions. Yes, Shahul, can you tell me what is the deadline for those three assignments which we has been given in the lab? Yes, it is Saturday, right? And in this function, how many functions you have to implement? In this particular assignment, you have to implement only two functions, which are just gonna be 6 lines of code that you have to type in. All the rest of the things you have to just copy and paste. If you see, peek operation is just to print the topmost element, which is going to be return top of data. That's it. This function is done. Peep operation is 5 lines of codes, maximum 5 to 7 lines of code. For that, I'm giving you 2 days extra. Today is 16th, and I'm giving you the deadline as 18th. If you plan properly, trust me, these assignments will not take more than a day. All your assignments, but still, you'll have got that liberty that till Saturday you've got time to do 3 assignments. See, if you don't work with deadlines, you will not learn. Whenever deadlines are given, try to complete it well before that so that you can think how you can improve on your codes. I hope you're getting it. The reason to give deadlines is just to make sure that you guys work efficiently. Okay, once you have finished writing your code, try to trace it again and again and check how you can optimize your code. Fine. So I feel 18th is proper. Okay, please try to do it and try to complete it. And trust me, it will help you improve. Okay, so let's now summarize the points which we have studied in the stack data structure. Assignment is clear to everyone? Yes, Paulson. All the see function definitions will be in one file, and all the other header file, for header file you'll have one stack.h, and for your main.c there will be one file. Okay. Yes, for linked list you have to do it separately, not for stack. For linked list you have, see, whatever is told to you, follow the guidelines accordingly. Don't jumble up the words. Okay, for linked list you have to do it separately only. But for stack and all that, you do it in one file. Because for stack and all that, it is going to take not more than 4 to 5 lines for array implementation specifically. Fine. Okay, so now let's summarize the points in case of the stack data structure. Okay, now let's summarize the points. Stack is a linear data structure. It follows last in first out principle. We saw when we were adding the elements how we followed this principle, and when we were deleting, we were following this principle. So any application that is following last in first out principle will fall under the category of stack data structure. One of the important point that is you have to remember, and when you go for interviews also you have to put forth, is that the insertion and deletions happens at one end, called the top. At the top only you are going to add the element and you are going to remove the elements from the same end. And then the time complexity to execute the important operation of stack, that is push and pop, will take constant time to execute, that is big O of 1. And you can implement stack using array or linked list. Now coming to the application part. So here we will study in detail about conversion of expressions. I hope all these points were clear to you. Application part we will discuss now. Anybody has any doubt with respect to any of this point? Aditya, you just zip the folder and upload it in OKPy. It should be possible because other students also follow the same uh, guidelines. Even they submit the entire folder. Okay, you just zip it and then send it. You can zip the entire folder. No matter if you have created 5 files or 6 files within one folder, when you zip it, it will come into one folder only. Yeah. Okay. Others, is anybody has any doubt with respect to any of the points of stack? Yes, Shiv Pratap. For peep operation, it is going to be big O of n, and peep operation is only for our uh, only for us to check whether we are able to get the proper output or not. When we are checking, let's say I want to know how many elements are present in the stack. In that case, I will be using the peep operation. But when you go for real-time applications of stack, you will only see push and pop operation. So here I am discussing only with respect to those those functions, the time complexity. I hope you're able to follow. Okay. Now let's see how stack is going to help us convert an expression. Let me just open those PPT for stack application. Okay. An expression can be represented in these three ways. That is, it can be expressed in the infix form, or it can be expressed in the postfix form, or the prefix form. And how are these different from each other? See, in an infix expression, you will have the operator in between the operands. For example, if let's say if you have a plus b, in infix is nothing but the one which we guys follow. Usually from our school times, we have been taught this method, that is infix. Wherein if anybody asks you to write an expression, we tend to write it in this format, wherein we will have the operator always in between the operands. Whereas in case of postfix expressions, you will have the operator at the end. You will have operands first and then the operator. Whereas in case of prefix expressions, you will have operator first and then the operands. But the question arises, why postfix or prefix when we already have an infix expression? So let's try to answer this question. Now let's say if I have an expression like this. Can you tell me what is the answer for this? Yes, can you tell me what will be the answer for this? What will be the answer for this? Yes, it is going to be 14. How can you tell me that it is 14? Okay, otherwise let's take one more example. What if I write it like this now? Now can you tell me what is the answer? What will be the answer in this case? 20. Can you tell me why this change of answer? See, I did not change the numbers, right? I had used here also 2 plus 3 into 4. Here also I used 2 plus 3 into 4. But in the first case, I am getting 14, whereas in the second case, I am getting 20. What is the difference? How the execution changes, Shahul? Can you elaborate? What is this concept called? Yes, it is the precedence that is playing an important role. Now here, when I write an expression like this, 2 plus 3 into 4, here I have two operators, plus and multiplication. So here multiplication has highest precedence than that of plus. So this part of your expression will be evaluated first. Correct? 3 into 4, that is 12. And then it is added, the result of this is added with 2 to get 14. Whereas when I provide the parenthesis, right, opening and closing parenthesis, in that case, this part of your expression will have higher precedence than that of multiplication. That is why this part of your expression is evaluated first. So you'll get 2 plus 3 is 5. 5 into 4 is 20. So precedence plays an important role whenever you are evaluating the expressions. Now with this understanding, let's try to answer the question, why postfix or prefix? If I have an expression like this, that is a multiplied by b minus c plus d, correct? So here, which part of the expression will be evaluated first? First, b minus c will be evaluated, correct? First, the b minus c will be evaluated, and then the result of this is multiplied with a, and then the result of that will be added with d. So when you give this expression to your systems, let's say to your system, if you type in this, your system has to scan this expression from left to right multiple times. Correct? Your system, what happens? It has to scan this expression multiple times in order to find which operator has highest precedence. Correct? And because of this multiple scanning, what happens? It makes your system inefficient, which leads to the time complexity of big O of n into n, which is nothing but what? This n is nothing but the number of operators that are present. So that many times you have to scan and check which operator has highest precedence and then evaluate the expressions accordingly. So if you give an infix expression like this, there will be multiple scanning required and hence there will be an inefficiency. To avoid this, you should have postfix or prefix expressions. Clear? Is the question clear to everyone? Why postfix or prefix? Please type in yes or no. Yes, is it clear? Please type in yes or no. Am I audible, guys? It's okay if you're not able to follow, I will repeat it. But please respond. Clear? Fine. So now let's see how to convert an infix expression to the postfix form. In order to convert the infix to postfix form, we will follow a two-step approach. We are going to first convert the infix expression to postfix form using one conversion algorithm. Then we will give this postfix expression as an input to the evaluation algorithm to get the result. So here you guys have to write two codes. One conversion code and another one is your evaluation code. Okay, we will discuss both these algorithms here in the class, and then you guys can convert those algorithms into the code format. Now, before going into the algorithm of conversion, let's try to manually convert one simple equation. Let's say this is my simple binary equation with single digits. I'll explain you with respect to the single digits here. Now here we have these many operators. Now here we are going to manually convert this expression first into the postfix form. Now can you tell me here which operator has highest precedence? Which operator has highest precedence? Parenthesis. So this should be converted first. Here what I am doing, I am just converting, I am not evaluating. So here I have 1 plus 1. Okay, so first I'll write operand 1, operand 2 followed by the operator. So here I have converted this 1 plus 1 into the postfix form. Is this clear to everyone? And I'll keep the rest of the equation as it is. See, the result of this 1 plus 1 should be used to divide with 4. Correct? So when we are converting, I am retaining this result in the flower brackets. I hope you are getting it. Then next highest precedence is for multiplication and division. So here 2 and 3. First I'll write the operand 1, that is 2, then 3 followed by multiplication. Minus 3 as it is, plus. Now this 8 divided by 4. Here I have two divisions, right? So 8 is first operand, 4 is the second operand, then division is the operator. This division as it is, and the rest of the expression I have retained it as it is. Now in the next line, you can see, you can treat this 8, 4 and division as operand 1 and 1, 1 plus as operand 2. See, the result of this should be divided with the result of this. Agree? So here what we are going to do? We are going to write it in this manner. Operand 1 is nothing but 8, 4 division. Then operand 2 is going to be 1, 1 plus followed by this division. Till here it is clear. I'm just manually converting it into the postfix form. I am not evaluating it. That is why I'm not writing the result anywhere. Till here it is clear. Anybody has any doubt till this point? Okay. So now let's move ahead. Here I have now minus and plus. So if we go from left to right, we will have operand 1 as 2, 3 multiplication and this 3 as the second operand. and minus is the operator which I have written at the end. Then the rest of the expression is as it is. Now this is operand 1, 2, 3, multiplication 3, and minus is operand 1, and this 8, 4, division 1, 1 plus division is operand 2. So we will write that, and plus is the operator. So this is the postfix form of the given expression. Please go through it. If you have any doubts, please ask. This is important, okay? In most of the interviews, people will give you expressions and they will ask you to convert it into the postfix form or prefix form. So you should know it. So please go through it, and if you have any doubts, please ask. Okay. See here, you have to follow the basic rule, Paulson, when you are dealing with two digits as well. Let me just give you a quick example on that. Let's say here I have 20 plus 32 into 41. Okay, and then let's say here we have plus 1. Now, given this expression, what is your first step? If you're converting it manually, what should be the first step? What is the first step, Paulson? No, I'm not asking the final answer, because unless I do this evaluation, I will not get, unless I convert this, I will not know the answer. So can you tell me, let's go step by step so that others also who have this doubt, they'll get a clarification on it. Can you tell me what will be the first step here? First step is to identify the elements here. Identify which operator has highest precedence, whether it is plus, multiplication, or again plus. It is going to be multiplication. First step is always, whenever any expression is given to you, you have to identify which operator has highest precedence. Now here we have multiplication. So I will start converting accordingly. I'll put the rest of the things as it is. So I'll start evaluating this. So 32 is my operand 1, 41 is operand 2, and multiplication is operator. Then plus 1. Now here next step is that I have plus. So this will be nothing but what? 20 is my operand 1, 32, 41 is my operand 2, multiplication, sorry, this is my operand 2. This entire thing is my operand 2. And then I will write the operator, which is plus. Correct? And the result of this now should be added with 1. So finally, it is going to be operand 1 is 20, 32, 41, multiplication and plus. This is operand 1. 1 is your operand 2 and then plus. So this will be the output. So go from the basic. This is how your postfix expression will look like for this particular infix expression. I hope you're getting it. Yes, Paulson, I have just given you a simple example. You have to explore more on this. And here you might have observed I am just explaining you about the binary expressions. Okay, and you guys have to explore more on these type of expressions and try to find out how you can do it, because if I just take this particular topic, 17 days is not enough to complete your syllabus. Fine, so I'm trying to give you the base, and with this base you have to build the things ahead. That's, as a programmer, you have to provide it, Shiv Pratap. How the compiler is going to differentiate between a 2-digit or a single digit, you as a programmer is going to write the code accordingly so that that differentiation is made. Fine, this part is clear to everyone. Okay, so let's see the algorithm for this conversion. Here is the algorithm. Again, I have written a simple algorithm. You can write a different algorithms as well, no problem. But I have tried to keep the things simple so that everyone in the class can understand the concept. So here what I have done, I have taken the same expression. Then I have taken a stack and a postfix array. Using this stack and this postfix array, I will convert this expression into the postfix form and then add those elements into the postfix array. Here I have added a dollar symbol at the end of the expression to indicate that this is the end of the expression. Okay, if you want, you can avoid this as well into your program. It's not necessary that you provide dollar only. You can provide any of your special characters to indicate the end of the string, or else you can avoid it as well. Fine. So now here you can see the first point is to scan the expression from left to right. So while scanning the expression from left to right, which means that you have to read this expression first. Can you tell me how to read the expression here? See, here I have taken the same expression. Towards the left side I have the algorithm, and here I have taken the stack and the postfix array. Here I am going to scan this expression from left to right. So first step is what? I have to read this expression. Now can you tell me how do I read this expression? See, there are two ways to read the expression. You can read the expression either as a string. Okay, you can take the expression from the user and store it in a string. Or else what you can do is you can read this as a string from the command line argument. You can provide the expression from the command line argument. The choice is yours. Either you read it in a character array, okay, or else you can read it from the command line argument. And then here in this infix to postfix expression, you have to scan this from left to right. And while scanning, to scan I'll take one pointer. And then while scanning, I will check if the item scan is an operand or not. Now you can see 2 is an operand. So I will add it into the postfix array and then increment the pointer. Again, multiplication is not an operand. So I'll go to the else part and check whether the stack is empty or not. Stack is empty. So I will push the item scan and then increment the pointer. 3 is an operand. Add it to the postfix array and then increment the pointer. Now we have got minus. Okay, this arrow is going little ahead. Okay, please don't mind it. This is actually pointing to minus here. This is not an operand. Go to the else part. Stack is not empty. We are here. So now check the precedence. So here you have to write one small function to check the precedence of the operators and compare the precedence of the item present in the stack with the item scan. Now you can observe that multiplication has greater precedence than that of the item scan. So here in this case, we will pop the item, add it to the postfix array, and then push the item scan, that is minus, and then increment the pointer. Again, 3 is an operand, add it to the postfix array, increment the pointer. Plus is not an operand. Go to the else part and check. Stack is empty, stack is not empty. So compare the elements. Now item present in the stack has equal precedence than that of the item scan. So in that case, pop the item, add it to the postfix array, and then push the item scan. Increment the pointer. This is pointing to 8. Okay. 8 is an operand. Add it to the postfix array. Increment the pointer. Let me just do this properly. Okay. 8 is an operand. Add it to the postfix array and then increment the pointer. Then division. We can observe that division. So division is not an operand. So we will go to the else part and check whether the stack is empty or not. Stack is not empty. So we will check the precedence. You can observe that plus has lower precedence than that of division. So this condition will fail. We'll go to the else part and we will add the item. And then we will increment the pointer. Let me just do it in this way so that I can adjust the slides as well. So again here we will have 4. 4 is an operand. So add it to the postfix array and then increment the pointer. Now we will have division. Division is not an operand. So go to the else part Correct? Stack is not empty. Now compare the elements. You can see they have equal precedence. So when they have equal precedence, we will pop the item and then add it to the postfix array. And then we will increment the pointer. And here you can observe when you increment the pointer, the item scan is now opening parenthesis. So when you have opening parenthesis, we will simply push that item scan. We will push this into the stack and then increment the pointer. Then we have 1 here. 1 is an operand, so add it to the postfix array. And then increment the pointer. Then we have plus symbol here. Now pay attention here, guys. This is important. See, when you have plus symbol and you try to add it into the stack, because it is not an operand, we will go to the else part. Stack is not empty. And here we are going to compare this opening parenthesis with plus. Now let's say when you have opening and closing parenthesis together, they will have higher precedence. Agree? Yes. When we have opening and closing parenthesis together, we can say that that particular part of your expression will have higher precedence. But here we have opening parenthesis alone. So what we will do? We will write our precedence function in such a way that this opening parenthesis will have lowest precedence as compared to all the other operators. So in that case, this condition will fail. And we will go to the else part and execute push item scan. That is, we will add this plus into this parenthesis. And then increment the pointer. Then we will have 1 here. 1 is an operand, so add it into the postfix array. And then increment the pointer. Then we have a closing parenthesis here. When you have the closing parenthesis, we will first check. This is not an operand, stack is not empty. So compare now. This plus is compared with item scan. As I said before, we will write the precedence function in such a way that these opening and closing parentheses will have lower precedence as compared to the other operators, which means that this condition will fail and we will go to the else part. And then we will add this item. Okay, we will first pop this plus, add here, because this condition will be true. Plus has greater precedence. So pop the item, add it to the postfix array. And then increment the pointer. Now we have reached the end of the expression. So when you reach the end of the expression, in that case, what you have to do is empty the stack. So when you empty the stack, you have to discard all the opening and closing parentheses and pop the items added to the postfix array. This is how you can convert the infix expression to postfix form. Please go through the algorithm. I'll give you some time to analyze the algorithm. Please do it. If you have any doubts, please ask. Yes, is it clear? Anybody has any doubts? Anybody wants me to explain it once again, or you are analyzing it yourself? Okay, Shahul says, ma'am, need some time, please. Okay, fine, no problem, Shahul. You can analyze it. Okay, I'll do one thing. I'll just repeat it once again. See, here what we are doing, we are getting, as I started the explanation with this, that we are going to have a two-step method, wherein first algorithm we are going to convert this infix expression to postfix form, and then take this postfix expression as input and give to the evaluation algorithm to get the result. See, here the main agenda is that we want to reduce the time complexity, because when you give the infix expression to your programs, what happens? The compiler has to scan this expression multiple times. But using this conversion algorithm, you're going to scan it only once, and thereby you're going to reduce the time complexity. I hope your this answers your question. Okay, let me just quickly repeat it, guys, so that it will help you to even analyze it yourself. See, here what we are doing, we are scanning this expression only once from left to right. Okay, and then what I'm going to do, I'll take one stack here. Okay, here what I'm going to do, I'll take one postfix array. And while scanning, I will first check whether the item scan is an operand or not. You can observe 2 is an operand, so we will add it into the postfix array. And then we will increment this pointer. Now here we have multiplication, correct? Again you will check whether the item scan is an operand or not. So here this is not an operand, so we will go to the else part, and then first check whether the stack is empty or not. You can observe that the stack is empty, so we will push this item into the stack and then increment the pointer. Till here it is clear. See, here when I say scan the expression from left to right, it means that here we are running one while loop. Yes? And then in this while loop, I am checking if I have this if and else conditions. So after pushing, I am going to increment the pointer. Again, here we have 3. 3 is an operand. Add it to the postfix array. Increment the pointer. Now here minus is not an operand. So we will go to the else part and first check whether the stack is empty or not. You can observe that stack is not empty. So we will go to the next if condition. Here we will compare the operators. Here you need to write one precedence function to check the precedence of the operators. So the item present in the stack is multiplication and the item scan is minus. So here we will compare their precedence. You can observe that the item present in the stack has greater precedence than that of the item scan. So this condition is true. In this case, we will pop the item, add it to the postfix array, and then push the item scan. Now what is the item scan? Minus, add it into the stack, and then increment the pointer. Here it is clear. Not to worry about how the program is going to check whether it is an operand or not, how to write this precedence function. Don't worry about this right now. First understand the concept. Then we will see how we can implement this part as well. I will discuss with you people. I will give you hints and you guys have to do it. Concept is clear to everyone? I can see only one person replying. What about others? Okay. Now the item scan is plus. Plus is not an operand. Oh, sorry, it is 3. Fine. 3 is an operand. Add it to the postfix array and then increment the pointer. Okay, let me just adjust this. Give me a moment. Okay, so we were here, right? 3 is an operand. Add it to the postfix array and then increment the pointer. Okay, here it should be plus. The plus is not an operand. Stack is not empty. Now compare the elements. Item present in the stack is minus and item scan is plus. They have equal precedence. So pop the item, add it to the postfix array. You can see minus is added here. And then push the item scan. And then increment the pointer. Okay, so here it should be 8 and division. Okay, correct. Now again 8 is an operand. So add it to the postfix array and then increment the pointer. Division is not an operand. Go to the else part. Stack is not empty. Now compare the operators. You can observe that plus has lower precedence than that of division. Agree? Plus has lower precedence than that of division. So this condition fails here. We will go to the else part and push the item scan. And then increment the pointer. Till here it is clear. Yes? Okay. So then increment the pointer. Now it is 4. Bear with my slides, guys. I actually updated my LibreOffice yesterday, because of that this issue is coming. Anyways, okay. So 4 is an operand. So add it to the postfix array and then increment the pointer. Division is not an operand. Go to the else part. Stack is not empty. Compare the elements. Now here we have two divisions. So they have what? Equal precedence. Correct? Because they are the same operator. So this condition will be true. Pop the item, add it to the postfix array. And then push the item scan. Clear? Yes, is it clear till here? Okay. And then increment the pointer. Now we are here. We have incremented the pointer. Now you can see that the item scan is an opening parenthesis. Correct? So what we will do, we will simply push this item scan and then increment the pointer. Now again item scan is an operand. Add it to the postfix array. Increment the pointer. Plus is not an operand. Go to the else part. Check whether the stack is empty or not. Stack is not empty. Now compare. See here, I have only one opening parenthesis. If I have both the parentheses, it means that they have highest precedence. So what I will do when I'm writing this precedence function, I will give this single, okay. Please pay attention. When I say single parenthesis, this is just an opening parenthesis. I'll give this opening parenthesis as the lowest precedence. And even for this closing parenthesis also, I'll give the lowest precedence as compared to all other operators. And if I follow that rule, I'm so sorry, this condition will fail because item present in the stack is an opening parenthesis which has lower precedence than that of plus. So we will go to the else part and push the item scan. Clear till here? Yes, Shahul. Because we have written the code in that manner, right? And we are providing this opening parenthesis as the lowest precedence. So when you compare here in this if condition, this condition will fail and we'll go to the else part and we will simply push the item scan. And then we will increment the pointer. I hope you are able to follow. Now here I have one. One is an operand added to the postfix array and then increment the pointer. Now I have closing parenthesis. This is not an operand. Go to the else part. Stack is not empty. Again compare. So the item present in the stack is now what? Plus. Plus has greater precedence than that of this closing parenthesis. So this condition will now be true. So we will pop the item, add it to the postfix array, and then push the item scan, and then increment the pointer. I hope you are able to follow. Okay, now we have reached the end of the expression. When you reach the end of the expression, you have to empty the stack. Discard all the opening and the closing parentheses and pop the items added to the postfix array. Now here you can observe that we have got our postfix expression in this postfix array. I hope everyone is getting it. Okay. Now let me ask you this questions. See here. Here I have written that if the item scan is an operand, how will your program know that this 2 is an operand? Or how you're going to write a program in such a way that this 2 will be treated as operand and this multiplication, all these things will be treated as operators? Yes, anybody? Can anybody tell me how do I differentiate between a number and the operators? How your program is going to be differentiating that? Very good. One way is ASCII values. What about others? Yes, ASCII is one thing. What is another approach? Pattern match. Like how? Can you elaborate on that, Shahul? Switch case. How you are going to identify that your program is going to identify that 2 is an operand only? 2 is digit only. How your program is going to tell you that? Switch case is going to be like you have to write so many cases. Like you have to write 0 to 9 cases Paulson in that. And then maybe for operators you have to write another 5 to 6 cases. It is going to be too troublesome. Easiest method. You'll have studied this in your C labs. You have written one assignment also on this. Isnum. Isnum is present where? C-type library. Yes. You can simply use the isnum function and check whether the item scan is an operand or not. If it is not an operand, definitely it will be an operator. So you can directly go to this else part and check. Stack empty case we have already discussed. Then comes your precedence. How do you check the precedence of different operators? Here you have to implement one small function, okay, wherein you are going to check the operators, precedence of the operators. Yes, can anybody tell me how do you implement this precedence thing? How will you check whether plus has higher precedence or minus has lower precedence or equal precedence? Yes, think on it. Until then, answer your attendance. Aishwarya, Vidya Sundar, Shahul, Ganesh, Sushmita, Shiv Prasad, Shiv Pratap, Ruchi, Paulmi, Paulson, Ramesh, Aditya, Sanket, Harsha, Deepak, Pradeepa, Sneha, Ramya. Harsha is there. Sushmita is also not there, right? Yes. Okay, do one thing. Think about it. How you can implement the precedence function. Think about it. Till here it is clear to everyone. Yes, Ruchi, you can do that way as well. You can do that. But there is one more easiest way to do it. Please think about it. Yeah. Okay. So I'll do one thing. Quickly we will walk through the evaluation algorithm as well. It's already 11:20. We'll do one thing. We will stop here because we'll run out of time. There is another class at 11:30. So I'll do one thing. I'll stop here. In tomorrow's session, we will continue. Fine? Till here, I hope things are clear to everyone. Okay, then I'll stop here. Thank you guys.